Let's come to the chapter Limitation of the Flow Filament Theory. I've taught you that we use a flow filament theory. We can use it pretty good if we have flow in a pipe, like in a pipeline or in a pipe inside a house, and then you can use a filament theory really good. And the filament theory was developed for pipe flows, more or less, or for flows into small rivers, and then it was used also for other problems in fluid dynamics. But of course there is a really big limitation. If you have fluid flow in an open pond or in an open sea, then the fluid will not only flow into one direction as if it is guided in such a pipe. Yeah? So the stream tube filament theory has some limitations, and there's a limitation in for compressible and incompressible fluids, and you can use it for a lot of problems, for a lot of flow problems, but not for all problems in fluid flow. Yeah? Here, if you see such a stream tube, I have explained this in earlier lectures. If you use a flow filament theory, you describe the fluid flow like a flow inside a pipe. Yeah, you have here an area where the fluid enters. You define the area geometrically, maybe by a circle or so, and then you describe the flowing of the fluid. You describe all the quantities, velocities, pressures, temperatures, densities and viscosities, but you can only describe it in one direction. And that's also where we want to start with the Eulerian formulation. Mr. Euler formulated this. He took the flow filament theory and formulated it in a more general way. He formulated the fluid flow in different directions. So stream tube flow filament theory for inviscid fluids. To describe the flow filament theory, you describe it in tubes, you describe it in pipes, and it's a theoretically assumption, but it is not useful if the fluid can flow, if the fluid can change the direction. So here we have again our filament. Yeah, we have here, if you use the filament flow theory, you have here an area where you make a balance for your fluid, where it enters the fluid. You have a special path length away, and if you have a path length and if you have the area, you can calculate the volume, and you can calculate the volume flow, and depending on volume flow, if you have the density, you can describe also the mass flow in this filament. But you cannot describe any change, or if some fluid will go into another direction, or if you have any diffusive effects or turbulent effects. It is not possible to use this flow filament theory for such a description. Okay, here's an example, short example for a filament theory. It's for example, a nozzle. Yeah, here we have an injection nozzle system for an injection of a fluid. This is a kind of venturi nozzle. Yeah, you have a pipe section, and at the side of the section you have another smaller pipe, and now you can inject the fluid, for example gasoline, from the side and inject it into this bigger pipe and mix it there, and can inject the fluid. Okay, so here's a small outlook for the flow filament theory, but I explained you can use it for injection, you can use it for fluid flow problems, but it is not really successful if you want to describe mixing or moving in several directions.